Hello, Dave here. Today I am modifying and repairing these robot arms that I had built for a friend up in New York area. Seems the design that I used just wasn't robust enough and kept breaking a servo. I'll show you that in a second. But these arms, if you've seen some of my other videos where I built these, they're driven with the lead screw. They go in and out. The claw and wrist opens and turns, and it also pivots. So part of the deal here is this lower servo was breaking. The servo gear was just busting right off the top of it. You see there. Here's the old one. I've already replaced, put a new one in there, and you can see how the top gear is just missing, just gone. Uh, if let me zoom in here. Oh, there it is, right there. You can kind of see how it the servo is captured down there in a bracket. It's all enclosed and it's really nicely supported. And you can also see that the servo horn comes up and goes through like a push bearing that has got bearings in it. So the idea is it swivels back and forth, and that push bearing is supposed to be enough to uh, support any kind of side pressure. This is this is kind of what it looks like in there. You can see the servo horn comes up and the push bearing grabs the collar and it allows the servo to move back and forth. So, um, but because of that side pressure that is still exerted on there, yeah, even though this is designed to hold it, it wasn't enough. It just busted the top of that gear right off. So, and it also happened in this other uh, arm, the second arm, and I'll show you how I fixed that in a minute. But just let me zoom out just a little bit here, so you can see that. I don't know if you can see that it kind of still has some play in it, up and down. See there? And that was enough to, when this thing rotated back and forth, it just snapped the top of that gear off. So, went to Silver City and bought some stuff. And I decided what I'd do is make a little bracket here. That let me show you that. This actually is longer, and I just cut it off so it would fit in here, and it fits right down in here, and that thing right there grabs this rod, and this bearing, it's actually a bearing, it swivels in there, it grabs this post and holds it all tight, so keeps that from happening. See there? Now this other arm, I've already implemented it, so you can kind of see how it goes in there. It grabs that half-inch tube right there, goes around it. These two pieces of I don't know what's called, channeling, I guess. It mounts that bracket, that bearing mounts onto the bottom one. They sandwich together, and pardon the jerky, this top bracket grabs this rod that comes through here. So, no, this servo is still broken. It just does it. So it just whips back and forth. So, but you can see how that turns in there now. Now it's supported down here and also up here. So there's no play at all. It's just solid. So there's not going to be any pressure on that little servo horn right down in there. You can see it. It's just, its only job now is to turn that servo horn and the weight above it, and not have to put up with any kind of weight. So that I think that's a pretty elegant solution here. The this rod is grabbed right here with a I guess, I don't know what you want to call that, some kind of grip bracket. It's all built in there. I put all that in there. And its only function is to hold this rod back here so that this will slide in and out. Like that, see. And this part never moves or goes anywhere or gets in the way, so that was a perfect spot to grab and support this function out here with some kind of bearing. So I think that's pretty good. Now the other problem I was having with this is, well, there's my robot. I'm working on him too. So there's motors that fit on the back of this. Right in there. Here's one of the motors. It goes up in the back underneath and fits up here like this. And it grabs, you can probably see it right there after I've taken this one out. It grabs on a 90-degree angle those gears, and it spins and drives this lead screw in and out. So let's see how that works. Well, anyway, getting back to my problem here, this was mounted under here, and the bottom of this motor, if it was set down wrong or banged, it would damage the circuit board. And you can always, this is a Hall effect encoder on here, and you can see how this one is already bent and broken. There's supposed to be two of them, another one over here. Here's the new motor that I'm putting on, and you can see the two Hall effect sensors right there that keep track of this magnet. So this one's ready to go back onto there, and this will be replaced too because this one is damaged, and you can see that the other problem is the wires get ripped off really easily. So how do I keep that from that happening again? I've got this little end cap that'll go on here and protect all that, so that'll never happen again. Okay, so that's an easy fix there. Once I replace those motors, I'll put this end cap on, and we're all good. Another problem I found was, if you'll notice that back in here on this other one, there's no lead screw like there is here. That lead screw was bent. I don't know how that happened. Here it is right there. You can't really see it, but it was bent enough. Well, maybe you can't see it, kind of flopping around there a little bit. It was bent enough so when it's turned, it would just make everything go boom, 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 and make it more difficult for it to go in and out. You can see how nicely this slides. Before it was this one, it was just catching in and out, so just making it very rough. So those are the fixes I'm implementing right now. Just thought I'd bring you up to date and show you this neat little thing that I came up with, and it works really good. Okay, and maybe I'll do a follow-up with this after everything's working. Maybe not. If not, y'all have a good one. Talk to you later. Bye.